what are we doing? Like, I started working for Runtastic 5 years ago, and I started working at a time where most of our backend services were running at rented hosts of a very big German web hoster. And it was a little bit of a pain because, as you can imagine, it was cheap, but it was very unstable. And we decided that we want to go on premise and build up our own infrastructure. And so we started 5 years ago with that. In the meanwhile, there was a lot of things happening. So our infrastructure, I tried to cluster that a little bit for you. So we're responsible for everything that makes up the whole backend infrastructure at Runtastic. So starting with the network and the servers, the physical servers, with the operating system, the software that runs on the operating systems, the databases, up to the stack where our backend developers will then in the end deploy their services to. So one could say we have some kind of base services or base technologies that we use. So we run everything on Ubuntu Linux, or most of it. And then we use something called Cisco ACI. It's a software-defined networking. So I'll talk a little bit about it later, what the idea behind that is. We use something like that's called Chef. Chef is a configuration management tool. So you can automate your software installs on your server so that you don't have to do that manually a second time. And now we use something Terraform. All that technologies here we'll talk a little bit more about later. So what are we running in the end? So in the end, I just tried to count. Today we have around 160 or 170 physical servers at the moment. Most of those physical servers are used for the virtualization environment. So all our machines are running as virtual machines, or most of the machines are running as virtual machines. Based on Linux, KVM, we use software called OpenNebula, which is just a very nice interface for starting virtual machines on Linux. We have a little bit of a hyper-converged setup. If you don't know what that is, it doesn't matter. It basically means that you run your virtual machines on the same hosts that also have your storage. So you don't have a dedicated storage for the machine images. You just run it on the same host. And then we have around 3,600 CPU cores and 25 terabyte of memory for our virtual machines. Then we have some core databases, and here I wrote it's physical or / a hybrid, because we have these three technologies that I would consider are our core databases. So we have a MySQL database, which is a little bit our starting point. So when we started out creating services, long before I joined Runtastic, it was only MySQL. Then at one point we added Cassandra, because you can imagine if there's a lot of people running and they create GPS traces, they need to be stored somewhere, and Cassandra is a very big cluster of 64 physical machines that just host these GPS traces, nothing else. And then we have, some time ago, we switched over from MySQL, because it's a single scale-up technology. We switched to use MongoDB as our core database. And also MongoDB is in that case special because those two databases are completely on physical machines. MongoDB is kind of a hybrid because it runs as a virtual machine but has its dedicated physical SSDs. Just a side note. So now it gets a little bit more interesting. The Runtastic backend system consists of approximately 30 backend services. I say approximately because there's some services that you would maybe not call a backend service. It's a little bit of a discussion between 25 and 30, I would say. And we try to, every new service we try to create, we try to do this microservice approach. So we create a service that has a very dedicated use case, and it has all its databases only for himself. So not these big core databases that are accessed by all the other services at the same time. So one service, its own databases, its own infrastructures around. Yeah, and as you can see on the very right part here, we really work with a lot of technologies in the meanwhile. So this, as you can imagine, a young company, everything is awesome. You try to use this and that, sorry, and then you come up with like a big stack of technologies. Would be too much to mention. Most of them are open source technologies or based on open source technologies. So that's what the infrastructure looks like. And one thing that you can imagine now, we're a team of 8 people caring for this infrastructure, but also for the office infrastructure, as well as our microphones here and the audio system. So there's a lot of things to do, as you can imagine. And so we decided at one point that we cannot just do the same tasks over and over and over again. So we started like very long time ago. There was the tale of the one ops guy that thought that Chef is automation. So we started with Chef at one point because we said we are idiots, and if we install that software on that machine and we do it the second time, it looks totally different. And it doesn't work. So we started with Chef, and Chef helps you can like describe how the whole thing should look like, what it should do at what point of the installation. And then when you say, I need this a second time because I have another web server that actually looks exactly the same, I simply apply the code to that web server and it will look the same, more or less. Yeah. So we ended up that, and that's the title here, that if one of the backend guys, like they're sitting over there, you know, and they're smiling now, yeah. When they came to us and say, hey guys, we want to launch this new app called Balance and we need a service in the backend for that, how much time would you estimate does it take you to create all that machines that we run here? So I would say in the end, for just a normal service, it would take us a day for, you know, creating virtual machines, then applying the Chef cookbooks and stuff like that. And I tried to show you a little bit how this would look like. So in the very beginning, we would call our data center provider because we decided at one point that we want our network to be outsourced to the data center provider, because there's one thing that where we are worse than in developing, and that's maintaining networks. So we called them, and it took like a week or 2 or something like that, and then they would have configured everything that we needed. Then after that, we would go to the software that I mentioned before, OpenNebula. It's a very nice shiny interface for creating disk images, virtual machines, and network IP pools and stuff like that. We would go there, start virtual machines that basically have nothing than an operating system. Would then, when we say, okay, you're going to be a MySQL database, then it would install MySQL or a backend service stack, then it would install JRuby or whatever was needed. And after that, we would have to do a lot of manual stuff, because Chef is very good in looking at a single machine and installing stuff on there. But if you have like clusters of machines, Chef is very bad with that. So there was a lot of tasks that would have been done manual. So we open our terminal, type stuff in, and would be happy maybe at one point. Then after that, we would clean up all the shit that went wrong, you know, because as you can imagine, we were automating a lot of stuff, but there was a lot of manual tasks in between. So also a lot of problems, a lot of things that we forgot. So cleaning up. And then finally, we would deliver our shiny new service to the backend and look at them. They are very happy. So job must be done good. Yeah. So you see, there's a lot of things. We were very proud of having automation, but actually there was a lot of parts not automated in our infrastructure. So yeah, only part automated was this actually. And then we said, well, why not try to automate the rest as well somehow, or at least as much as possible in that whole picture. So yeah. So we started a little bit to look around and finding the little pieces that you need for the whole infrastructure. So we also had this always in mind. We were not happy with how the networking part would be because it was very manual with phone calls and phone calls back and forth because they did not understand what we needed and we were not good in explaining. And yeah, in the end, we found something that's called, and if you're in IT, then you will know these two letters, SD, because everything is software defined at the moment. So we started software defined networking. And the idea behind that is, if you're like me, and I said before, I'm very, very bad in networking. I don't understand anything, or not that much at least. And so what this SDN does, it's like an abstraction layer to network so that people like me, and maybe you, understand what's happening there. So it basically says not what IP address does this machine have, or do I have the right firewall rules in between, and what gateway do I have to use, and what subnet. It basically doesn't care about that part. You just say this machine is part of this, is of this type, like a web server, and this machine is of the type database, and then I say a web server is allowed to talk to a database. And no matter when the web server comes up, where it comes up, what IP address it has, what host name it has, it doesn't matter. If it's a web server, then it's allowed to talk to everything that's called database, for example. So very, very, very simple explanation. So there's a lot of things that you can do, but in the end, it's something, it helps a little bit understanding what happens in the network. So that was the first piece that we found. Another piece we already had in place, that's the tool OpenNebula, because what we did basically was we would use our mouse and click it through that web interface, and then said, I need a disk image with 5 gigabytes or 200 or whatever, and I need this many CPU cores, that amount of memory, and it should have this IP address. But OpenNebula also provides an API. So we said actually, if it has an API, it can somehow be automated. So you can do some kind of a web request, an HTTP request, and it will then do whatever you would normally do by clicking through the interface. Yeah, then we had good old Chef. So the thing that we already knew, it's actually very hard to Google the thing, because every time you Google chef and cookbook and recipe, you will come up with a lot of websites that are not about chef. But anyways, at one point we found the right websites, and we learned about how to write this Ruby code and then also to apply it to machines. There was a lot of learning involved because we did a lot of very, very bad cookbooks in the beginning. Exactly, that was chef. And then no matter what you do, in the end there will be some commands that you will have to execute, so bash or something else. Anyways, will always be some kind of one of the pieces. So we had a lot of different pieces, but they were loose, so you had to do the networking part, still you had to do the virtual machine part, the chef part, and then tie everything together. So we thought, okay, how can we do that? And there is a tool called Terraform. It's an open source tool. Can just download it, don't even have to install, just run it and it works most of the time. And yeah, we say Terraform is some kind of the umbrella that covers all the pieces in our infrastructure. So actually wanted to write the one ring to rule them all, but yeah, the umbrella to rule them all is also fine. So in the end, what you do is you code the whole infrastructure. So it looks a little bit like here. So you have a lot of files. In the files, you just describe what you need. For example, you describe, in ACI, I need these types of services that I talked before, and I tell which services are allowed to talk to each other. I just write that in code. Can be in a Git repository or something. And then I do the same for the virtual machines. I'll do the same for the databases, for the chef cookbooks. And in the end, I have a little bit of a configuration file even, and then I can say how should the service that I want to spawn be called. For example, for our balance app that we launched yesterday, it would be called nutrition, and it would be in production environment, and it would have stuff like that, IP addresses and whatever. And the good thing is, in the end, you have code that you write once for one service, because if you have several services that actually look like look the same in the end, and there's only some differences like the name and the number of machines that you want to spawn, and maybe the permissions that it has towards other services. So maybe the one service is allowed to talk to the other one, but the next one not. So the only difference is a little bit of configuration in the end. So the idea behind that is that if one comes and says, hey, I need a new backend service, I just go and copy our template folder and I just change some configurations here, and then I run Terraform, and then it will, in our case, run between, depending on how much it has to create, between 8 and 15 minutes. And after 8 and 15 minutes, it would have spawned up all the machines that you would need, would have installed the software on top, would have maybe upgraded the machines if you want that, and reboot, and then in the very end say, okay, I have a cluster of 2 machines and I need to execute these commands in that order on the 2 machines, and it would tie together the pacemaker cluster or whatever, or MySQL slaves and masters. And in the end, you would have a running service after a very short period of time. And the very good thing is, it's very reproducible. So there's not that human being that forgets to type the one command, or that instead of creating a disk with 100 gigabytes, creating one with a terabyte or 10 gigabyte, which would be even worse in most cases. And in the end, it always looks the same. And if you have a problem, and in most cases, we even don't do backups if we don't have a state that we need to backup for a service, but we just say it's much faster to create the service new instead of backing it up and then restoring it. So that's now the idea that we have. And that's we're currently using that a lot, because we are migrating our whole infrastructure from a data center in Vienna to a data center in Linz. And for that, it was the initial idea to do that. So we have to recreate the services in a lot of cases, and we can just do that in a very short amount of time. Yeah, and that's it basically from my side. Any questions? Really that bad?
Do you have any special documentation besides Terraform and Chef, or is the documentation in the source code?
You mean about the services? Well, so the question was if we have additional documentation besides documentation for Terraform and Chef. Not really at the moment, because it's very much work in progress. We document the basic stuff, and we document a lot in the source code in the end. Yeah.
Do you deal with initial setup stuff, like your newly set up VM has to talk with your Chef server to register whether it's actually trusted to exec the configuration? Do you do that with Terraform, or?
We do all that stuff with Terraform. So we try to simplify it a little bit. We have like what we call base services. Like this is services that would every virtual machine in the whole system would need to talk to that service. That could be DNS or the time servers or Chef or like a repository server, something like that. And we just say have like a common contract that would be applied to every machine, and then it would be allowed to talk to Chef. But it's terraformed. Yeah.
I'm talking more about a challenge response type of scenario where the machine must be known to the other one. We're not talking about network or security, just the app that is accessible on the machine and that's needed for it to set up has to know the other one.
No, we don't have that.
Okay.
So while we're at it, How are you managing secrets? Do you have a vault in place or something? So when machines, so you already know what I mean. Okay.
Yeah. So secrets is a little bit of a topic that has a little bit of history. So what we did, we have Chef has a built-in mechanism for that. So it's called an encrypted data bag. So it has encrypted file stores where you can manage secrets with, but it's actually not super nice for the use case. And for now, we don't have anything in place, but we're planning to, and Vault is one of the ideas. But it's not said that it's going to be Vault, but Vault is very, very likely, actually. So. Good, then. Oh yeah.
Do you have any code examples of Terraform?
Yeah, if you give me a minute. Is it readable for everyone, or shall I make it bigger? Good. So basically, what you see here is a folder called PRD, so it would represent our production environment. And what you see here on the right side is all the basically the representations for every service. So there's a service that's called relays, resources. So here we have the nutrition service that I was talking about before. So one Terraform plan is, that's how it's called, for every service that you need. Can be backend services, can also be some infrastructural services that we have. And then within one plan, so we're in nutrition now, we can see that's just the way you do it. So it's up to you how you create that. So Terraform will just go into that folder that you set and run every file in there, no matter what. It will not take the order into account, nothing. It will just load everything, put it into order, and then run it. So we just said we're going to split it up a little bit and say we have something that's called globals. It's basically some configurations for where Terraform should connect to, which Open Nebula cluster, ACI and stuff. Then we have a plan for a file for every part of the service. For example, this one would create Elasticsearch, obviously. Then HA proxy for doing load balancing in front. We have a man cached here, a MongoDB. We need to configure the network. We have Sidekick, which is our asynchronous workers that do the asynchronous jobs. Then we have the JRuby application itself. It's Trinidad. Then we have some variables definitions, and here we have the Terraform TFVars file, which will be the configuration. So basically, you actually never have to change these TF files, because that's in the template. You just copy that, and then all the changes are made in this single file here. And for example, if we then talk about network, basically what it would do is network ACI. It's a module that configures the ACI. So it would just create a tenant, because ACI has tenants with a certain name. It will create a description, service name. So in this case, this would be nutrition. It would tell which. That's basically something that you don't need to know in the end, but it would tell the ACI which VLAN it should use for this specific service and stuff like that. And then it would create the same representation of what you created in the ACI, also in the virtualization environment in Open Nebula, so that the virtual machine that is spawned up in a specific network in Open Nebula is then can be matched to what we configured in the ACI here. And yeah, it again has the same stuff, VNet and VLAN names, and yeah, then there's only some variables again in the end. And then we have, for example, what should we take? Let's take the Elasticsearch. So what we do here, we created some code ourselves, so some providers and modules. That this module here will just set up an Elasticsearch cluster. It will spawn virtual machines. It will connect to a Chef server that you configure here. It will tell which version of the Chef client it should install on the machine. It says which service name, which environment, how many CPUs, how much memory should I enable VNC so that I can connect without SSH, or the images size and stuff like that. Then it would tell, okay, here's some configurations about the JVM memory, the version of Elasticsearch it should install. And then it will also tell, because we have a load balancer in front of the Elasticsearch cluster, it will also tell which ports shall it use, what is the max, just some settings, you know. And in the end, this will then spawn up machines. And if you give me 10 seconds, then I will show you a little bit more of the code. So this would be the module that was called in the other service. So you can reuse your code. So just creating modules and then use it in your plans. So in the end, what would happen here, and that shows a little bit better, it would create a chef role with a specific configuration here in the first part. Then it would create, that's here this template thing. It would create a virtual machine template in OpenNebula, and this template then knows about all the CPU, reserved CPU, how many CPU cores should be shown memory and stuff like that again. Yeah, and then in the end it would also create disk images, because it's a database cluster, so we don't want to lose the data, so we create persistent images with the data on top. So this is done here. And yeah, and then it will, if everything is done, it will instantiate the machines depending on the number that you specified in that configuration file. So this is then the configuration file that I talked about. So actually, since I said everything that we saw before can just be copied because it's the same for every service, you just have to go to that file and fill in the variables here. So what environment, what is the name, the VLANs, and the IPs. That's something that we now do as operations manually. So we take it from a list and add it here. Could also be automated in the end, and it's a plan. To do that, so have a pool of IP addresses and VLANs, and it just takes the next three, and it would be fine. So, and then you see here, for example, what ports should be used and stuff like that for the service itself. And then here's this is these contracts that I talked about in the ACI. So there is this base services contract, and where this would allow, you know, the basic stuff that every machine needs. And here you see it configures which version of JRuby should be installed and some other stuff that is needed. And then at the very end, it just says here how many instances should I spawn. And the good thing is, if we now we have 2, and if our balance app is very successful and we say, okay, we need a little bit more, we just say, for example, 10 here, and we run the plan again, and it will just add the missing 8 machines, and we'll leave the rest untouched, and then it's fine and running. Is that clear somehow?
One more question.
Yep. Okay, the question, yeah.
Okay, and how do you deploy your services on those machines?
That would be actually something that one of the backend guys could answer. Andreas, maybe you want to do that? Because I'm dumb and I don't know.
Well, actually, all our servers are the Ruby servers, and we just use Capistrano, and that takes care of the rest. So as soon as we get the boxes from the operations team, we just deploy on them, and that's all pretty much automated from our side too.
And if you have a new version of your service, deploy it over your old version or start your new servers?
It will be at the moment deployed over the old version simply. Yeah. You can just ask and I'll repeat also. Yeah.
A short question. You specifically mentioned that most of your servers run on Ubuntu in the
Yep.
beginning. I still don't see the reason why it's specifically Ubuntu.
It's just was just a decision at one point. There is no specific reason for doing it. No question. So it's just we started with Ubuntu and we never had the reason to go away. But we will go away as we will start with OpenShift, which is container, and this is based on Red Hat. So we'll change in future. Yeah.
One question: did you consider Ansible in the beginning before you choose Terraforms?
Terraform? Yeah. So Ansible and Terraform are doing a little bit of different things in the end. So you can. There's a lot of overlap between Ansible and Terraform, but Ansible is also more doing the same things that Chef is doing. It's better in some parts and not as good as Chef in some parts, but it's more or less doing the same. So it's configuration management, and you just connect to a machine and apply specific parts here. We're using Ansible in some areas, specifically if you use software that already comes shipped with Ansible playbooks, then why should you write your own stuff in Chef or something like that? So we use Ansible for that. That's specifically everything that comes from Red Hat in most cases has Ansible playbooks available, so we use that for Ceph and in future for OpenShift. But Terraform is a little bit higher abstraction level than that. So that was the reason, yeah. Thank you.
So, of course, you'll get the official speaker badge for your laptop. I'm gonna visit tomorrow to check whether it's there. Okay, yeah, you can put it inside. Armin just told us that they have 160 to 170 servers right now, which means one server for everyone. So I guess he'll invite us to get one server after we leave or when we leave. Yeah, let's move forward. Peter.
My name is Peter Schöppl. I'm an attorney at law. I'm working in Linz actually, especially on the fields of, for example, data protection, commercial law, corporate law. In the law firm Rechtsanwaltspartnerschaft Blümke und Schöppl, my colleague Stefan, he's also here working more litigation and arbitration. So just a few words to my law firm. Today we have the topic of the GDPR, the General Data Protection Regulation. So the countdown is running to the GDPR. It has started a few years ago, and now it will come into force on the 25th of May 2018. There's not a lot of time to comply with the GDPR. It's just now 7 or 8, 9 months. And there's still a lot of things you have to think about for the new rules we will have with the GDPR. Tonight I'm gonna talk just about a few parts because it's a huge issue. There is so much which is changing. There's also a lot which is still the same, but it's just here to give you an idea what the new things are and to make things to make you look on this point. So we'll speak about the reason why should we comply with the GDPR, what's new about the consent, and also about the issue of what we do have to do to comply with the GDPR. Just a few technical words on the GDPR. It's now a regulation. It has been the old data protection rules were a directive, so now the regulation is binding, and which means on the 25th of May we are in the issue. And like I've heard just before, it won't be enough if you just put all your data in a room, just make them mess up and then close the door. That's not the best and the wise idea. It is correct, it is a trending topic, but there is a new girl in town, everybody looks at it, but there's still a lot of reason why we should look at it or her. So respect my data protection authority. There's the first change with it. We had the Datenschutz Kommission in Austria. Now they have a brand new name. It's the Datenschutzbehörde. So, as you can see. And there we start with the reason why we should comply with the GDPR. You may say we are complying because it's a law. That's a good reason, but it's not enough good reason. They put a much better reason to comply with the GDPR because they started to have new fines. You can see that we have now new issues. The old fines were up to 25,000 euros, so that's for now like a very small amount, and we have got much better fines now. From the point of view from the European Union, from your point of view, it got much worse, and that's the most important reason. So if you are thinking like you are a small startup just starting your business now, you're this guy just laughing about 4% of the worldwide turnover. But as we all know, we are here in the rooms in the office of Runtastic, and that's Runtastic now. If they have a problem, and I don't think that they have a problem, but like we've heard before, setting up a new app or a new feature in an app within 1 day. Did I get that right? But it was too complicated for me. Means you have to look for two principles which are imposed by the GDPR. First one is data protection by design, and second by default. So from these are not brand new principles, but from now on, if you don't comply with the rules of the GDPR, the Data Protection Authority has right, for example, to come into your office if there are massive infringements versus the law, and to look on your data and how you are proceeding the data. So from now on, the authority can really serious can bring to your organization serious problems. If you don't comply with the new issues, and like you can see here, we have now fines up to 4% of the worldwide turnover, or 20 million euros, whichever is higher, and that's a good reason to comply. What else do we get here on this issue? The right to complain to the DBA. What's the DBA? It's the Data Protection Authority, like you have seen before. Nothing new. Then you have the right to a judicial remedy. Just to give you a short idea, I've said that before. In Austria, we have in the first instance the Datenschutzbehörde, and in the second instance the Bundesverwaltungsgericht. Venue for proceedings, what does it mean? Where do we have the proceedings? There's a change in this issue. In former times you had the proceedings where the organization is established. Now you can have still the proceedings there, or alternatively the proceedings in the at the residence or at the place where the data subject is working. Representation of data subjects. Now it's explicitly allowed for association to build them up and just to, they would say, protect the rights of data subjects. So we will now have a lot of new Darth Vaders who are going through the legal world of Austria and just to make to impose use claims on your organization. Compensation and liability. We still had compensation and liability, but now we have material and immaterial damages. For example, just think about your personal data has been disclosed by an organization, your financial reports. If you have for this reason financial disadvantages, of course you can ask for this financial disadvantages for the damage of it, but in addition you can now ask also for immaterial damage. What does it mean? Immaterial damage is like if you can explain that your reputation is reduced, that you don't feel in the same way you felt before, which is in Austrian law a very difficult issue. We still don't have the same way like it's for the damages like in other countries, but the more and more we also get immaterial damages in Austria and also now in the GDPR. This was just the first picture I wanted to give to you. The picture was about why should we seriously comply with the new GDPR. There were some news in there. Now the next points. Like I've said before, many things are changing, but not everything. Territorial application, which means there is also a broader range now in the territorial application. We are shifting now to the market rules. So if you are offering goods and services in the European Union, you have to deal with the GDPR. Doesn't matter if you have an establishment or not. Consent, we'll talk about this issue later. Rights of data subjects, we'll also speak about this later. 72 hours data breach notification. 72 hours data breach notification, it's brand new. also in the GDPR now. If there is a massive problem, a massive data breach, you have to notify this data breach within the 72 hours, which makes some serious problems, what I think, to a lot of organizations, because, for example, if you have this data breach maybe on Friday, and in Austria, every organization is closing on Friday, and then time is running till you have the time to make a proper notification to the DBA, to the Data Protection Authority. How to comply with this, we'll speak about that later, but for sure every organization, remember about that, should have somebody who is responsible for the new GDPR. It might be a data protection officer, but it can also be just some responsible guy. It's that's for sure when the breach happened, because otherwise you have the next problem that you would have to say, okay, the data breach happened 2 weeks ago. Now we are realizing that the data breach is happening, so you have a serious problem to explain to the Data Protection Authority why you then can comply with all your data, why you have no clue about the data leaks, and which is at least the same problem like the data breach you had 2 weeks before. Okay, increased compliance obligation for controllers. Who is a controller? A controller is an organization, in German, just to give you the word, is the Verantwortlicher, and it's an organization who decides how and why data is processed. So this is, from my point of view, the company which gets first the data, the personal data from the data subject. And then it's deciding, okay, we are processing the data, or we are shifting the data to a processor. For that, we can ask, what is a processor? A processor is an organization which has to, which is processing personal data in the way it has an order. It is commanded by the controller. Just to give you an example, like from a law firm, I'm getting the personal data, and then I'm shifting this data to another organization, which is, for example, just saving the data, and that's, I'm just telling them, just make sure that all the personal data is very well saved in the manner that is in completely compliance with the GDPR. So that's the relationship between the controller and the processor. It's a very important relationship, but it's not that good. For example, if you're just processor with the new GDPR, both organizations are liable under the law. Appointing a DBO. There are two reasons. What is a DBO? Data Protection Officer. For two reasons, you have to appoint a DBO in your organization. If you're working with sensitive data, or if you're monitoring personal data, each case in a large scale. So if you're doing that, then you have to have a DBO. What is, for example, sensitive data? It's for just there are a few examples: data about religion, data about your health. That's in the core of personal sensitive data. If you have no obligation to appoint a DBO, it could be still advisable to appoint a DBO. Why should it be advisable? Because a DBO has the task to make sure that all the data, all the personal data in the organization is in compliance with the GDPR, and he has to be in connection with the DBA, the Data Protection Authority, and the data protection officer is also, for example, on the website. So for businesses which have to comply in a very well manner with the GDPR, it could be advisable to say we have a DBO, and for this reason you have also perhaps a marketing advantage. Cross-border transfers, that's maybe one of the last points from the point of an organization where you have a kind of an advantage. We still have with this new rules a lot of issues how to define them, but for sure we can now have contracts with other organizations out of the European Union, and based on if these contracts are if there is a consent for this contract by a DBA, by a Data Protection Authority, you can use these clauses, and therefore you can deal with these organizations outside the European Union. Well. Sorry for that. The one-stop shop. Every organization has now, which is established within the European Union, has now one-stop shop principle, which means there is one DBA, one authority, which is responsible for you. That's also a very small advantage compared to the directive, which the rest is just full of disadvantages from the point of organizations. From the point of data subjects, they have now more rights, but if they really gain advantages in the dealing with their data is not for sure. Another small advantage is increased harmonization. I said that at the beginning. We have now one rule, which is the GDPR as a regulation and not as a directive. And the directive has to be imposed with national laws. The need for consent. What is legal consent? For the consent, we have no complete new concept for the consent. What does it mean? We still have the same elements, which are consent has to be freely given, has to be specific, has to be informed. But what does the GDPR now say about the consent in addition is it has to be unambiguous, which means without doubt, and it has to be a clear affirmative act. So if there is doubt about the consent, always think about that now the burden of proof has been shifted from the data subject right to you as an organization. What does it mean? Now if you have a problem with some compliance with the GDPR, you have to prove that you got a legal consent. And the next question would be, what's about the old consent we still have in our deposit? They might be still valid. There is no problem with an old concept as long as it was given also under the same circumstances I'm describing right here. Method of content, of obtaining content can be like till now ticking boxes, but always be aware of the fact that it has to be informed and it has to be measured by the purpose. You don't.
So consent can't be implicit. I am using the service, thus giving consent.
Yeah. Consent can, for normal consent, this probably two questions. If you need for as an organization for your services the personal data, and it is clear that the personal data is needed, like for example in the HR business, they need the personal data from an applicant. So you don't need the consent from him that if he's applying for some position to give the personal data to another enterprise, if it's specific for this one, because it's clear because of the Vertrag, of the contract. So therefore, you need no consent at all, because it's because of the contract, like I just said. And if you need a consent, because the personal data is not needed for the contract, it has to be clear. It hasn't to be in written form, but it has to be very clear. And if you have problems at the end, and you cannot show a clear consent, a clear affirmative act of a consent, it's your problem. Silence is no consent, as I've written here, and consent must be distinguishable from other matters, which means it must be this. If you have general terms of conditions, you can put in the consent, but you have to distinguish from the rest, and you have also you have to have the possibility just to say yes to the general terms and no to the data protection declaration. So we're gonna skip this. It's just an important issue. What you have to have is for the. We're coming now to the next point, to the rights of the data subject, and they have to have the rights at the beginning, before the registration or in the process of the registration. That's very important. If you tell them what their rights are, you are probably too late. Yes. We have said that before, the 72 hours. Here just the rights of the data subjects. Transparent communication means you have to, like I said before, you have to tell the data subjects just before what rights do they have. Therefore, because now we have new rights on the GDPR, you should revise your GDPR. That's brand new, the first one. Time limits for complying with the rights of data subjects. Under the old GDPR, under the old data protection, we had the right to comply with the rules within 8 weeks. Now it's just 1 month. If it's very complicated, you might have the possibility to extend it for another 2 months. Right to basic information, right of access. There is not much or not that of a change in these areas. Fees in respect of access requests. Now it's expressly forbidden to ask for fees for the first inquiry. If there are repeated inquiries, you can ask for some money, but it's explicitly said for repeated. So if the second one is kind of different, I wouldn't be sure if it's a repeated one. And this one, at this point, can bring a lot of problems to organizations. For example, if people who want just, to make your organization for whatever reason a really hard life, they are just always, asking on the rights, asking on what personal data is stored about them, and so you may produce a lot of, you have to produce a lot of efforts just to comply with the new rules. This is one of the basic messages at all, that you should find in your organization in the next months ways how to comply with the GDPR, not only legally but also effective. Therefore, you should set up data policies. You should have somebody who is responsible for these new proceedings to answer fast to inquiries, to answer if it's possible automatically generated, and to answer in a way which is sufficient to the law. And you don't want to have somebody who is always working on the issue by going to the servers and to find out what's going on with the data for this data subject. Sorry. I'm coming to another right of a data subject, which is the right of data portability. This right is also brand new. I shifted the other issues because we're still 1 minute. Now you have the obligation, if you have an inquiry of a data subject, that you have to send him all the data, all the personal data, in a readable way. And you have also the obligation that this data is sent from your organization to another organization chosen by him. Therefore, you have also to care that this works out. It can be also an advantage on the other hand. So if you bring new or your clients by this way, that they are asking other organizations like competitors to send their personal data to your organization, they have to comply with this inquiry. That's also one brand new right. Computer says no, that's not allowed anymore. You have the right to get a decision by a person, and well, not this decision. Just put in the most important issues, how to comply with the GDPR. So make sure that you have a data policy, that the data policy is for by default and by design in the handling of the new projects. Make sure that you have an update on your data declaration. Make sure that you have a responsible person in your organization, and make sure that all the processings in your organization are written down, the procession of the personal data, and that you now analyzing these processions for the risks to data breaches. If you do that, you did a lot for the start, for the next month, and then you will see that the issue is very important now to you to seriously comply. What we have also here is employee training. That's also very important. So this was just a few points, an update on the GDPR, and well, that's the first information. Thank you. Just I forgot, I put a checklist on my website for the GDPR. So if you want to download the checklist, just be free to do that, and then you can start with the first steps. Okay.
Everyone speaks about the fees for commercial organizations, and I've heard a lot of presentations like this, but no one spoke about the fees for non-commercial organizations, educational organizations, or governmental organizations. So, how high will be the fines for them? As they have no turnover.
Yep. The GDPR counts for all organizations, which means they also have to comply. If there are no exemptions, for example, for defense, national defense, security, police, and so on, they have to comply with the GDPR. We will see that. I mean, it's yeah, because still it's not enforced now. So they are starting on the 25th of May. And it's a very good question, because I'm also very nosy on this, but there is no experience about that. No judge can decide now on this issue, and we will see how it works out. Yeah, of course. It's either the turnover or yeah.
So this is all for personal information, where you can identify a person. So what about if I send somebody an email, just an email with surname, last name? Do I have to get consent before they can store my email address or something?
You're sending as a data subject. Pardon.
Yeah. Okay. Okay. For example, I send you an email.
Yeah.
And you're storing my email address. For sure, because you're
the way you have the script, your email address, first name, last name, it's personal data, and you had an inquiry to me, so I don't need your consent because it's part of your inquiry. But I'm not allowed to store your email address after this inquiry has been done, and the law says you are allowed to process personal data only for the specific purpose. So you're sending me an email. I've just a question on employment law, and then we are writing. I give you the answer, and after this case can be closed. There's no more reason that I'm allowed to store your email address. I have to delete it.
Okay, that means every time I get an answer, you have to delete my email address again.
Yeah. No, but if you ask for this right, that's the way it is.
Besides the fines for the companies, is there also a personal liability of management or of the DPO for the obeying of the law?
There's no personal liability of the DPO. And according to the Austrian law, there's also no liability from the point of a data subject of the management. You know what I mean? If, for example, the management has doesn't comply, the management of an Austrian GmbH doesn't comply with the GDPR, and the board says because that you didn't comply with the GDPR, we have massive fines. So I'm gonna make you responsible for these fines. That's possible, but the data subject can just ask for the limited or the organization. No.
Okay, I have one more question about service providers. That specifically means like hosting providers or people who are actually writing your software or maybe storing your software in a cloud provider. If we talk about controllers and processors, if you brought the example like somebody sends the data to you, you're the controller, you're receiving the data at the first point. So if I'm providing cloud servers for a customer of mine, I am actually the person who is getting the data the first time via a web form or something. So does the new law somehow involve the service providers in a larger scale, or how is liability or how can I be sued per customer because I provided a service for you, because I have a contract with you, because you're hosting your website at my place, for example?
In this case, I'm the controller and you are the processor. So if you don't comply with the rules and I can prove that it was not my fault, it has been your fault, you are liable for the damages and not me.
Okay, follow-up questions regarding the 72 hours things.
Yeah.
Just in case, I'm as a hosting provider detecting some data protection issue of a customer of mine. Am I reliable for like also making some notification to the ministry, or is it just the obligation of the customer, the person hosting the application?
If you're just detecting this problem at the controller's place, you should be liable within this relationship between the controller and the processor, but you're not liable to the data protection authority, because you didn't make this problem up.
Yeah. Okay, thank you.
Sorry, going back to the email question. Do you have to proactively delete my email every time I send you one, or do I have to ask for that?
The law says now that you have to define time periods to comply with the GDPR. When you time periods, you are deleting personal data you don't need anymore.
So there's no need for me to get active, and you still have to delete all the emails that I sent you if they're not relevant.
Pardon?
So I don't, as a data subject, I don't have to get active for you to delete my data. You have to delete it anyways.
Yeah. In this case, it's for this case we have no consent, because it's part of the relationship between customer and an organization. So in this case, to store the email can be justified in different ways, because you say, I might have to know my customer, so you can store it, or you can say, me as an attorney, I might be sued by my customer for some wrongdoing, so I need to store it for at least 3 years or longer, because you have 30 years of total years where you can be sued on some damages. But if it's not based on consent, more on the contract, the time you can store it is not that strict to see, then it would be with consent.
Yeah, one more question, then we'll probably.
This law applies to any companies, right? Not only technology companies.
Not only?
Not only technology companies. So also your
to
company.
all companies, yeah.
So I'm thinking that this 72-hour, what is it called, that period, that will be a much bigger issue for non-technical companies, like a law firm, a construction company, than for technical companies, because like Runtastic has, I don't know, 8 people that are constantly monitoring their servers, but I guess your law firm probably has nobody that's constantly monitoring your IT infrastructure.
Me.
Yeah. So what's your opinion on that?
No, just like I said before, if it's based on the relationship between customer and the organization, the commercial firm, it's not that strict. But if it's based on I'm just collecting data and this data is not necessary anymore, there you should define a legal time frame where you say, and after this point, I'm not storing anymore.
Okay, thank you very much. I think there's probably more questions.
Thank you.
Thank you. So if there are any more questions, please come up. Peter is going to be here for the rest of the evening, most probably. There's beer, so he's going to be here. We're going to do a break for about 40 to 45 minutes. Now there is Bresel, Oktoberfest here. And yeah, see you later. We're going to have another talk. Thank you.
Ja, die Leute haben es wir werden einen Haufen Fragen kommen, glaube ich. Es gibt so viele Details, an die jeder denkt, weil es trotzdem jeden betrifft. Ja, ich will eine kurze Frage stellen.
So I was rather surprised that I'm not the only Linux user this evening. So that's already the second Linux notebook this evening. Yes. And that's the hell with it. So let's get started. So it's called GraphQL Legends because I really liked that game when it came out, and it's nothing to do with that it's legendary or anything. I just like the graphics, and therefore I decided to give it a title. So actually what it's about is this. So those are the buzzwords of the project I'm currently working on. And you see there's not much missing from whatever is fancy at the moment. So you definitely find yourself something that you're interested in there. There are a few buzzwords missing still, so let's say Docker, Kubernetes, Kafka, Vertex, and a lot of other stuff which I couldn't fit on the slide. But that's actually what it's about, and it's about how I succeeded in introducing GraphQL in a real business use case. So it's an enterprise application, and with enterprises it's not always that easy to bring in fancy new technology that makes sense, and in case of GraphQL I think it was a success, and therefore I decided to give this talk about how this all was going to happen. So about me, so I'm already freelancer for some time, and I'm developing software for 11 years. Before that, I was in graphics design already as a freelancer. When I came on to my first codes, I was rather surprised, and I really liked the magic of programming. I decided to go studying in Hagenberg to get some skills, and during my study I already started to develop software. And our company, so since 5 years I have a colleague, David, and we together founded Octobyte. So 2 guys, it's easier to get larger contracts than one alone. And yes, we divide our work. So I'm mostly a web developer and server-side developer, and David is client-side, so Android, iOS, and also the web. What I didn't mention, you see there's developser. So ops is some side interest of mine. That's because whenever I enter a new project, for some reason there's no continuous integration, no single click or continuous deployment or anything, and I really need this to work efficiently, and for that reason, that's most of the time this is the first thing I got to do in a new project, is at least get some sort of continuous integration to work. So, and therefore you need to know a bit about servers, and single click deployment is the second part, and then you need to know about the infrastructure. So that's the ops in developer. No, we're not hiring, so we're very happy together. If anybody of you is a freelancer or wants to be one, you can contact us. We always know somebody who needs somebody, so just let me know. Okay, the mission. So the project is for GE, which is General Electric, and it's a subdivision in Austria, in Tyrol. It's Jembach, and they have a project called MyPlant, which is, I'd say, mid-sized. Maybe it's a rather small IoT project. In effect, it's about they have about 25,000 assets in the field, and an asset in this context means a gas turbine engine which produces power, and those engines are used for example in hospitals as the emergency power supply, or in the Australian outback for coal mining and stuff like that. And those assets are distributed all over the world. 25,000 isn't that much as a count, but every such engine has between 100 and 1,500 sensor inputs. So those data item is some value at some time from some engine in that case. So up to 1,500 such data points every 30 seconds from a connected engine. So that's mid-sized, because this is some amount of data, but nothing in comparison to the data produced in here or soon in Linz. So Runtastic definitely has more data, but it's fast data. So who knows what? No, I don't ask. So fast data means this data has to be processed very soon, so we can't store it and do batch processing of it. We rather need insights quickly. So there was a buzzword in the slide before, which was predictive maintenance, and that means that we try to detect failures on engines before they are going to happen, and we want to maintain those engines before they get before they get worse, essentially. And therefore, this data needs to be processed in real time, and also all the web clients, all the clients, web clients, CLIs, and mobile clients work with real-time data. Yeah, my part in all of that is actually I was hired as a web client developer for some enhancements on their existing web client. Yeah, which turned out to be a re-implementation of the whole system, and I had a 1-year contract. We did it in 6 months, and then there was another 6 months left to do something else, and then I started to do some server-side optimizations, and for some lucky reasons I had the chance to do this in Scala because they didn't know better, and they thought it was just temporary, and now it's rather big and it's Scala. Not everybody's happy about that, but yeah, I am. Yes, and that's a JSON API which provides data for all sorts of clients. So we have CLIs, we have internal services which access this API. We have the mobile clients, and we already starting to have SDKs for customers so that they can use the data from the API for themselves in their own applications. Yeah, and yeah, I killed some of their legacy components. In the meantime, legacy components were 5 or 7 or something. Now it's microservice architecture in the background. So we're at about 30 services now, and a lot of servers. And I imagine that we run at the same cost as Runtastic does with much less data, because we run on AWS. So AWS is very, very expensive. Okay, so the shiny new toy is GraphQL. And GraphQL actually is sort of a replacement for REST services. So REST services is the traditional approach right now to deliver data to different sorts of clients. And it has some limitations, and Facebook 2 years ago released the spec. So GraphQL actually is just the spec, the protocol, how you talk to a server. And they released it, and GraphQL has some very interesting properties. So it has strict types, so you have really a typed API, which isn't true for JSON APIs in general. You have relational or graph support. This means it can handle relations very well. It has a very flexible model of how you can fetch data from an API, so you can decide on a very fine granular level what you actually want from the server in terms of data. And you can fit it on top of every infrastructure. So that's really a point for GraphQL server implementation. You can overlay this to any sort of service you already have in place. So you can wrap it over an existing REST service just as well. Okay, to start off, I'm going to show some examples. That's how you query a GraphQL API. I'll do this first so that you know what we're actually talking about in the next 20 minutes or so. I'm not sure how I handle the microphone here. So, is there any way? Yeah, that would be really nice. So, every query. Yeah, that's a job, right? So every query starts with a query, and what you also see here is that the tooling integration for GraphQL is already great. So that's an IntelliJ plugin I'm using here, and I'm connected to a service in the background. And you can't read this, right? So let's go into presentation mode. That's better, right? So, and then one. And as mentioned, an asset is actually an engine in the field, and it has a lot of properties. Let's say time zone, and a lot more. So auto-completion works from the IDE, and what you actually get is some data formatting is, I think this is going to work on a second. So what you actually get here, I'll try to handle it. So that's the benefit, right? So I'll defining some sort of data I'd like to have, and reflected in the response is this exact format. So I'll have an asset here, I'll have the fields I requested, and nothing more, despite the fact that every such asset has a lot more to offer. So whatever I want to have in addition to those fields, I can declare them. Then another nice property is that it's batch query able. Oh, that was wrong. That's not so easy. I'm used to doing this with two hands. No problem. I try. So this is all on a single endpoint, just to be clear here. And once more. And executing. In this case, I have a single query and I can do multiple queries with a single request. So that's another nice property. And then there's much more. Let's do something more. Relation support is, let's see. So. And what I'm building here right now is a graph. So that's what's the big advantage of a graph-like model to query. I'm going into an asset which is part of a site, and the site has assets, and assets again have the same fields that we have outside. And you can nest it, this stuff infinitely deep, and you get a whole graph of the data returned. Formatting is not so cool on the right side here, but you get the idea, right? So that's what graph is actually for. And at the moment, I have to add, a lot of IoT projects that are trying to hire us already built their whole model architecture in native graph databases. So that's a trend actually coming. I'm not sure if it's really reasonable to do everything in a dedicated graph database, but it's definitely, for some use cases, it's very advantageous to do so. So are there any questions so far? Because now we're getting into more details. So I think the concept is clear. What who has used a graph database or GraphQL already? Is there? Not so much. Okay, not so many. Is there many? Okay. So who is the developer in here? Okay. So I just wanted to make sure. Otherwise, it might get boring for some of you. Okay, so yeah, and what I didn't show off is you get autocomplete, you get strict types, you get arrow highlighting, and all the stuff you like in IDEs, and that's really nice. And the whole thing came into being. There were several challenges in 2017, so GraphQL was just introduced into the API, which actually brought me to consider GraphQL again. I had my first experience with it 2 years ago, but this year I got really into it. So one problem with generic REST APIs, I don't know who of you is already has had similar experiences, but over time you have two choices to create an API. So the typical endpoint you use to deliver data to your clients is mostly not enough. Either it has much too much data or not enough. And you start either providing specific endpoints for specific needs. That's one solution to the problem. And there's a lot of stuff not working with this approach, because typically there's just one property missing from such an endpoint to render it unusable, or there are way too many fields to make use of it. So I'm not doing any of this. That's just mock what I did there. So whenever a client developer asks me for a specific for endpoint, a specialized endpoint, I say no. So there's no discussion with me about this directive, otherwise must come from way over whoever develops the client. So I'm really strict on that. I'm very opinionated. But the way I do it is this way. And this whole form you see here is the documentation from a single endpoint, and it didn't even fit on the screen. So that's the other way you can do it. So parameterize a single endpoint, and this gets also, on the one hand, as you can imagine, new developer accessing the documentation is not going to be very happy with this, because it's not clear what's doing what here. And then there's another problem with this approach is some of those parameters require each other and some don't, but all are optional. So you have to know which of those to combine to actually get the result you want. So that's also a problem, and it's very hard to get documentation to actually provide info about such complex endpoints. So that was problem number one. And then there were two stories actually this year. One was that we like to provide custom dashboards, which means customers can build their own reporting landing pages where they build a query and we render charts, lists, whatever UI components there are. And those should be available as landing pages for customers. So you have lots of data, lots of different data sources, and you need a way to deliver fast. So landing pages should be, right? And this meant to having a batch query. And then a second story, which is actually the same, just with a different time horizon. From my perspective, we needed to provide some sort of reporting, which provides static reports on an interval at a certain time, a point in time, and creates a snapshot and provides different formats to the customer, CSV, XLS, whatever they want, static images, PDF, and so forth. And that's the same requirement from a data perspective as the one before. And those three issues perfectly matched GraphQL, and I requested to get a spike about this. So I spiked, GraphQL for the win. It should solve all our problems, right? And as mentioned, I requested a spike, got 2 days time to investigate in frameworks, technologies, how we can integrate it, and that's what I found. So this didn't look like anything I wanted to get into production in an enterprise system. So, right, this looks just semi-professional, okay. It's a Spanish developer, and I had other libraries from Spanish developers. They like fancy logos, and they always choose names where you're not so sure if this is the real thing or not. So I had to investigate a bit how, or if this is an option. So what you always do, check the license, check the GitHub commit log, check the pull requests, check the issues, look into the source code and all the fancy stuff, check the features, clear? And check at least 2 other frameworks as well. I did this with a Go implementation and a Rust implementation because that's what I'm currently interested in. And yeah, Sangria it was. They really had good code. There were some already large customers that were using Sangria, and they are funding Sangria, by the way. And we implemented it with, or I implemented it with Sangria. Yeah. Okay, then now it's going to be code. And just give me a hint that you had enough. So if I overdo it, just tell me and we can stop at any time. Okay. So two things. One thing is this is a library, mostly library code, and it's Scala. So Scala isn't a very common language. So I know not many of you are used to the syntax, but for comparison, I have just added some small Java class here. That's the data item I was talking about before. So it's not completely implemented, and I'm not even sure if it's correctly implemented, by the way. Yeah, it has a lot of methods, getters and setters and stuff, and in Scala, this and 3 additional fields looks like this here. It's a case class, and all the stuff you've seen before is just boilerplate for writing actual code. That makes sense. Yeah, and a data item, as mentioned before, is one of those data points where hundreds per engine are incoming every 30 seconds. And to wrap this type, this is a Scala type, to wrap it into a GraphQL type, and that's the whole point of having strict types in the API as well, is this. So my convention is always to have some domain model name, and the GraphQL implementation just appends this type stuff. And this is a wrapper and creates a GraphQL schema type from, so for all the fields that are in there, this is all you have to write in Scala with Sangria to actually get the schema out of this. And yes, this in the background, this uses macros. So Scala still has macros, not for the near future, but at the moment there is still macros. Okay, then a bit more complex case is now the asset. I just added some fields, and as you see here, we have some embedded objects already here, and the data items, which is a sequence of this data item. Yeah, there can be many. And the GraphQL schema without a macro, if we write it out by hand, would look somewhat like this. So essentially what you're doing is adding the documentation and then define all those fields. And here's the part that's interesting. So for every field you define a name, the type, so that's the GraphQL type here, and a function. That's this scary part here. So you know this from JavaScript maybe, but that's a function. And this function is executed to resolve the value when queries are executed. And to don't have to write all those boilerplates, you can write functions like this in Scala. That's rather new to most developers. So not even Kotlin is going to have this, but that's also a function. So, and a bit more complex a function is then this data items part, because this is querying data from a separate service. So all those are resolved on the object that's given into this type, but this one uses an external service to fetch data from somewhere else. So that would be an asset then. And some of those queries, like here, use arguments. That's what I'm going to describe here. So as we've seen before in the queries I wrote, you can have the round braces, normal braces, where you can add parameters to your query, and that's how you declare such an argument. So in this case, the simplest case is we have an ID, which is a long type, and the more complex case would be this one, where we want to aggregate some data items, and in this case, that's the data item name and what type of aggregation we want to have. This is going to be an enumeration. We come to that next. So here we do the same modeling and input type here for GraphQL, and then this argument type allows us to request a list of aggregations from our service later on. Yeah, enumerations in Scala, this is one way to write them. There are multiple ways, and this is heavily discussed in the community, but that's the easiest way. And for GraphQL, you'll write it like this. So you'll add documentation and you'll say what type maps to what, and all the transformation from to JSON is done automatically in the background. So you're dealing in your services on the server side. You're dealing always with such entities that are actual Scala types. So I don't know how much details we need, but yeah, that's an aggregation result. So we have the name, operation like before, how many items, and what value the operation did aggregate to. And yeah, doing a result type here. I'll go over this quickly because it's repetitive. So I just add documentation here. And then to aggregate something useful, we need more than one asset, because if I want to, for example, have the number of engine starts and I want to aggregate, I'd rather have more than one asset. So I'll define an asset, a collection, which is just a list type of an asset type. So we get a collection of assets, and on a collection of assets you can aggregate data. I don't go into details here. This is query optimization, but there's a resolve function which allows us to resolve aggregates over multiple asset data items. And the last part for the schema, so we're still defining just the schema. There's no service implementation yet. A query, that's the outermost part. Actually, that's the outermost part we wrote. So a query is the wrapping around all the inner query stuff. And this query has an asset and an assets field. That was the query I showed before. So assets and by ID in this case. And in the other case, we have multiple assets, and in this case, there's a list filter which allows us to filter on assets. And then we create the schema. And last but not least, we execute it. And when you run this, I'll come to the part above later. So that's the schema we defined. We give this executor comes from the library. We get the schema. That's what we provided. The query asked is the stuff that gets posted to our endpoint where GraphQL is hosted. The user context is the object. You've seen it before in some of the resolvers. You provide this object, one instance per request, and you can handle sessions. You can provide service instances and stuff like that. So that's the injection context, and it's handled through the whole graph. Wherever you have in your graph, you have access to this context. And then variables we haven't talked about, but you can do sort of prepared statements with GraphQL. So you can extract the variables into a separate object and provide them independent from your query. And yeah, an exception handler and stuff like that, what we all like. Okay, and then, and if you execute this, it's going to return the JSON for whatever the query was. So at this point, we know the query did not contain anything what we can't provide. Given that our services deliver the correct data, what comes out of this executor is actually already this deep graph of however deep you nested your query when requesting the data. So are there any questions so far? No? Okay. Is anybody tired already? Should we stop? No? Okay. Okay, so next thing is there are some issues with querying a graph anyhow. So if you do the same, say via REST, you do say 10 requests or 100 requests. Say you have some entity and you want to get all the, let's say we have a post and some comments, and I want to show the first 10. We do 11 requests, 1 for the post and 10 for the first 10 comment IDs. So that's not the case with GraphQL. We can embed them directly, but on the server we want to provide a mechanism to do this more efficient than querying 10 times into the database. And for that, there are some helpers in the library which allows us to, for example, collect the IDs from the functions that were invoked above on the resolvers, and then do one query and resolve all, say, 10 comments in one go. And that works deep into the graph, and you can provide custom such query optimizers as well. And this works really well, and it's an enormous speed boost in comparison to requests anyhow, but also if you compare it to invoking all those stuff separately. So in case of Scala and this implementation, it would all be invoked concurrently, by the way. So it's all async that I'm showing you here. And that could overload your backend systems rather quickly if you have, say, 13 or 15,000 queries in parallel against some resource. So I know only one database that can handle this that would be Cassandra, because Cassandra's driver provides back pressure, and they handle the case where you do 20,000 queries in parallel. Okay. One other point, refactoring. So a GraphQL API never gets outdated, so you can support any client for as long as you like, and that's really interesting. I just did some super simple stuff here. We have some entity with location information and a GraphQL schema for it, and then we want to refactor this whole stuff to modify the location, get its own object, and embed the whole object into a nested field. This is typically rather weird change. It doesn't look much, but if you have a lot of different clients out in the field, especially mobile clients which do not update for years sometimes, changes like that are going to break stuff. So not with GraphQL in this case, because we can refactor it to support both models. We can support the old and the new. In this case, the ID is unchanged. We keep latitude and longitude here, and just provide a deprecation reason here. So the documentation from now on will no longer show those fields, just only if you explicitly ask for the documentation for the deprecated stuff, but they will be hidden otherwise. And we provide the new field which resolves the new embedded location. And what we change in the resolver is that we have a nested location with a latitude. So on the server side, you can already work with the new models, just the API provides an old representation still. So that's really nice, and that has been an issue in my current project several times already, and that solves a lot of those troubles. Especially, I'm really a fan of refactoring, so I like to rework a lot, but what you never can touch are domain models, and now I can. So at least for everything that's GraphQL only, which isn't that much, by the way, at the moment. But I hope it's going to get more. Yeah, then query complexity is another issue with GraphQL. So you've seen, I can provide a query for this project which would query about 60% of the whole data set that we have in all databases and across all services. So with one query. We don't want that, so we have to have a mechanism to prevent scenarios like this. And what's also provided with this library, and this is a recommendation for the GraphQL specs, is that every field can have a complexity assigned, and this complexity can be either a static value, and it defaults to 1, I think. And you can have a function that calculates during query execution how complex is this going to be. And those are summed up across the whole query. And before the query is actually executed, okay, 5 minutes, it would cancel the query and throw an error that the query is just too complex to execute. And you can adjust this, because if you're in a batch environment where you have a dedicated machine that batches those queries, you can set higher ratios, and in a live API you set lower ones. Okay, yeah, we worked through this, so I didn't expect that you were as patient as you are, but let's see. So I'm already coming to an end. how did this all turn out? So this looked rather complicated, but effectively the core data objects were implemented within a single sprint. So with 2 weeks time, I had a setup running which provided most of the data. So 60% of the data was covered with those 2 week sprints. It's read-only, so you can use GraphQL to update data as well, but I ignored it this because I don't see any sense in that. But for querying, it's very convenient. There were 3 days in the next sprint where I only worked on optimizing queries, like I've shown you before, because I couldn't anticipate the bottlenecks beforehand, but on a running system you can already detect where those are going to be. And I initially expected some maintenance overhead because we still maintain the REST API, so also new features are implemented in REST, but there's actually no, if I change my services, GraphQL just takes the new services, and yeah, so far no overhead on that. Yeah, we have new features which are GraphQL only, but they're rare at the moment, and there's a lot more to be implemented in the next year or so. So there's a lot on the agenda. Okay, so a few things that were very helpful from the infrastructure that was already in place. So one thing is what you really want to have is services that provide a multi-get by ID. So say in SQL terms, this would be an in-query with an ID, because a lot of those relations are by some sort of ID, and you want to batch query by 1,000 IDs, for example. That's really helpful. I had to implement it on some services, but most of them had this already. This user context object I showed you before is at the point where you dependency inject, so that wasn't in the code examples there, but that's really convenient to have all your instances available within the query, and everything async is, especially for execution time, an important factor, because all those resolver functions you've seen, they execute in parallel. So to get it fast, you have to have an implementation that provides async. You have to have async services, and the GraphQL implementation should provide async responses. So, and I'm a bit over time, I think, but not much. So are there any questions now? Because that's the finishing line. Yep.
Are there any GraphQL databases, so I don't have to program my own backend? I can just directly connect to the database.
So I think if you want to go with a graph concept from a database perspective, it's better to use a graph database. So GraphQL can be used together with some other graph database, but actually what it provides is you can overlay it over any service. So that's the whole point, I think, of it, because Facebook wasn't willing to re-implement everything for that. And it's built to support, it's especially good for microservice architectures from my point of view. And yeah, you can, if you really want graph only, use a graph database. So,
what's a good graph database? Maybe that's what my question is.
Yeah, we had, I think 3 years ago, we have investigated Titan, which was open source at that point. It's an overlay over Cassandra, so it's implemented in Java, and it was rather okay. At that point in time, I didn't have a real need for a graph database, so I never tried it in any real-world project. And I don't know, I think it is, at least Titan is no longer open source. I'm not sure, but, and there is, how is it called? There's some Java database as well. Yeah, Neo4j, exactly. Yeah, I never had a look at that. So. Okay.
One more question. Sorry.
Yeah.
Okay. Is it possible to make it, well, I call it real time, so
yeah. Okay.
right that I always get new results?
So maybe that in general, so GraphQL specs are in V2 right now, and they support several new features. One is a subscription model, which allows you to get real-time updates on those predefined GraphQL fragments, and that works very well. The second thing they support with the V2 specs, but isn't implemented in the frameworks right now, as far as I know, is streaming. So if you have very large result sets, they can stream it in chunks or also in combination with subscriptions. And yeah, and there are, but yes, it's possible to do subscriptions.
No more questions. So thank you very much. Let's give one big applause to the hosts, to Runtastic, and to the speakers. Thank you very much for hosting us today. And if you think, wow, this was a cool talk, I can do it even better. I have very cool topics, cool ideas, cool projects I worked on. Just contact any one of us Technologieplauscherl guys, or do a pull request and just hand in your talk if you want. We are already full for the next Technologieplauscherl in October at Johannes Kepler University. But for the one afterwards, we got one talk today. There might be one free spot. So just approach us if you have something to do. Yeah, that's it. Thank you very much once again, and have a nice evening. So Christian might lead you around in the office.
Yeah, so if someone is interested in having a tour, especially in the 5th floor, as there is our engineering area up in the 5th floor. So if someone is interested, my colleagues will be here. So just come here and we will give you a tour in the 5th floor.